We can get finished. Rate of change is one of my favorite things to do. It's nice and easy, but there's a couple of things that you need to remember. So the rate of change, you guys know how yesterday we found the patterns in our tables? So essentially, you found your rates of change, but we're linking together the dependent variables because we had patterns on the left column and we had patterns on the right column. And now we're going to put those things together. So that pattern we're still going to look for. The change in quantity, so rate of change just means one quantity is changing at this rate and the other quantity is changing at that rate. I'm just going to flip back to yesterday's notes so that you guys, oh, that's domain and range. That's not what we did yesterday. Here we go. So when we look at these, our independent has a pattern of 5. And our dependent, oh, this one doesn't have a linear pattern. We'll go over here. This independent has a pattern of 5. Dependent has a pattern of 9. So we're going to link those two things together. Okay, now I'm going to flip back to the actual thing we're doing today. So here's the deal, ladies and gentlemen. Dependent variable goes on top of the fraction. So this would be our range values. And our independent goes on the bottom. So those would be our domain values. We also know that on a coordinate plane, we have our x and we have a y. We have an x and we have a y. Which one's associated with domain, the x or the y? X. So this is our domain. And the y is associated with our range. Sorry, I'm spinning that around. Had to write it sideways. Do you guys need the curtains closed? Yes. Yes? Would that be helpful? All right. Okay, so range or dependent variable on top. There we go. All right. It's really dark because we're in a dark classroom. Let me see if I can turn on some lights here. Maybe that'll help. There we go. That's a little bit better. So we're linking all these things together, and they have different names, but we have y values on the top and x values on the bottom. So depending on how you remember it is going to make the most sense. So sometimes we call the rate of change, we call it the slope of a straight line. Call it the slope of a straight line. And we're going to be using this. We're going to be doing a slope formula in chapter 6. So that's coming up. So we're going to make this a little bit fancier. Okay. So ladies and gentlemen, M is the letter used to represent slope. I do not know why it's the letter M. Lots of people have asked me, and I still don't know why. So the letter M represents slope or rate of change. Okay, so rise, excuse me, rise, thank you. Rise deals with what goes up and down. Is that the y or the x? The y. So the rise deals with our y values. And the run, so we run left to right, that is our x. Okay? Now we're going to use some fancy Greek letters here. This is the Greek letter delta. And in math, delta means change. So when we talk about delta, the triangle, and that's, we've all heard of delta at this point. The Greek alphabet's at the back, that's why I'm looking at the back. So it's the change in y values and the change in x values. So delta means change in mathematics. Okay, now we're gonna actually, all that. So that's all the mathy stuff behind it, the stuff you have to know. So now we are going to figure out the rate of change for this graph. Is this a linear function or a linear relationship? Yes, you are correct. Do we know why? Just looking at the graph, how can I tell? Straight line. Okay, it's a straight line. So this is linear. So if we know it's linear, we know that there is a consistent rate of change. So we're going to identify the dependent and independent variables. So which one is the independent? Where does independent live? Let's slide up here. Independent, where does it live? It's the domain or it's the x. So independent is the domain or the x. So looking at this graph, which one's on the x? Time. So what's our independent variable? Time, right? All right, so let's talk about dependent now. So what's the other one? If it's not time, it's volume. Okay, so I'm going to assume that you guys I'm hoping that you all feel confident enough to do that on your own. Maybe you're just not confident enough to say it yet, and that's okay. But you really should, at this point, be okay identifying the independent and the dependent variable. Because if you can't do that, it's going to be really hard to figure out the rate of change if you can't figure out which one goes where. Okay, so ROC. What does ROC stand for? Anybody got a guess? Rate of change. Okay. I'm not a big fan of typing long things, so I like to abbreviate them when possible. So we're going to talk about what's happening in between the points on our linear relation. So the rate of change is the change in the y values divided by the change in the x values. So all you're going to do is you're just going to look at 2 points, and I'm going to pick 2 points. I'm going to pick this point here and that point there. And let's talk about them. If I start at this point, so I'm starting at, what's this measurement here? What's the height of this one? 1,000. And where's the height of the second one? Where's the height of this one? 3,000. So how much did I travel up? If I was at 1,000 and now I'm at 3,000, how far did I travel? 2,000. So we moved, so the change in y, so from here to here, was 2,000. It doesn't mean I'm at 2,000, it means I've changed. I've started at 1,000 and I've gone to 3, so I've moved 2,000 liters up. Okay, now we're going to deal with the x values. So where did I start here? 20. And then I traveled to over here. 60. So how far did I travel? If I started at 20 and I went to 60. So 60 minus 40. 60 minus 20. 40. So we traveled 40. And another way to count it is, hey, this is 20, this is another 20, because we know each increment is 20. So 20 and then 40. Okay? So we got to divide this. We got to divide this. Yeah? So the zeros are gone. And 4 goes into 200. How many times? 50. Okay, now let's talk about units of measure. What was on top? What was on top? The volume, right? And what was volume measured in? It says right on your y-axis. What was volume measured in? Liters. Okay, and then this one was time. The x value was time, and that one was in minutes. So our units of measure are going to be liters per minute. So and notice it's a positive number. So we know that for every minute, what's happening to the volume of filling that water tank? What's happening? Every minute, what goes into the tank? 50 liters. Okay, so that's the purpose of this, is doing this. And then we're gonna create equations of lines and all that other stuff too, but this is the starting point of it. Okay, I'm gonna flip the page. All right. There we go. Determine the independent and dependent variables. So what is our independent? Independent is time again. And dependent? Volume. I think I heard somebody say that. So again, my independent is located on my x-axis, and my dependent is located on my y-axis. Okay? We're going to determine the rate of change. So I'm going to ask you guys this time. Okay, so rate of change is the change in the y over the change in the x. So you're going to pick 2 points. We'll pick this one, and we'll pick that one. It doesn't matter if you do the x first or the y first, you just have to make sure they go into the fraction in the right place. So let's talk about our y. Let's talk about our y for a second. So where am I starting at? 0, and where am I going? 2,000. So 1,000, 2,000. So the change in y is 2,000. And we're going up, right? Everybody would agree with that?
Yes.
Okay, good.
Negative?
What's negative? We're going up.
No, but you go from 2,000 to 0.
No, I started at this point.
Oh, sorry.
Okay? All right, so now, again, I'm starting at this point, and I'm going from 60. Which way am I going, though? Going left. And on a number line, what numbers are left? What is left of the 0? Negative number. So if I travel left, I'm traveling a negative distance because I'm going backwards. So I was at 60, and now I'm at 40. So how far did I travel?
Negative 20?
Negative 20. So because I moved left, it's a negative value. When I move to the right, it's positive. When I move to the left, it's negative. Up, down seems pretty easy. Like up is positive, down is negative. Okay, so those zeros cancel each other out.
Negative 100.
Negative 100. And then what are my units of measure? Liters per minute. So what does that mean? What's happening? Every minute, what's happening? Am I filling up the tank? It's losing. I'm draining the tank, right? Like I'm taking stuff out. So every minute, I'm taking 100 liters out of the tank. Okay? So it doesn't necessarily mean anything negative. It's just depending on what your water level is doing. Am I draining the tank or am I filling the tank? And ladies and gentlemen, that is rate of change. How easy is that? Fairly easy. A couple of quick things. Know your lefts and rights. Know your ups and downs. But also you have to have your change in the y goes on top. Your dependent goes on top. Your independent goes on the bottom. Yeah, Rahat?
How do you know which way you're moving, left or right?
Because you always start at the same dot. So I started, this was my first dot,
Okay.
right? So the bottom one was my first dot. So I knew I was going up to get to my second dot, and I had to move left to get there.
Oh.
So you can't switch. You have to start at the same dot every time. So Rahat, if we pick this one, as my first dot,
Yeah.
so let's do that one. So if we pick this one as my first dot, I'm running out of colors here. I'm going now down 2,000. So if I go down, that's a negative 2,000. And I'm moving to the right 20. So that's a positive 20.
-100.
And I still get the negative 100 liters per minute. So if you do it right, you and I can pick different dots and we will get the exact same answer. Like you could have picked a dot way up here. So maybe let's try that, ladies and gentlemen. I want you to pick 2 different dots that I picked. You can't pick the first 2, like these 2. You can't pick those ones because I've already done those. I want you to pick one of mine and then one of these. So we'll call this dot 1, dot 2, dot 3, and dot 4. So you have to pick one of mine, so either 1 or 2, and then either 3 or 4, and I want you to do the rate of change and see if it's the same.
I did 1 to 4 and I got the same answer.
Mm-hmm.
1 to 4 actually really nice.
Okay, so I did 1 to 4. So I picked point 1, and, oh, sorry, you can't see that. I picked point 1, and I measured it all the way to 4. So I looked at the change in height first. So I went up 6,000, but I went left 60. So up 6,000, so it's positive, and then I went left 60, so it has to be a negative 60, and I still got the negative 100. So it doesn't matter what dots you pick, you will still get the exact same answer. Do dots that are easy for you to do. Like, I mean, all of these are pretty nice because it's dividing out nicely. But like when you're looking at a graph and some of the numbers aren't nice, if the 2 dots furthest away from each other have like nice numbers that are easy to subtract, use those. Like, so work smarter, not harder. Okay, that is today's rate.